Good day, students. Today we want to look at this question which came in February, March 2021. In other words, this is 0620 component 62, alternative to practical. This is February, March 2021. You have a question which was saying all the concrete contains calcium carbonate. Calcium carbonate reacts with dilute hydrochloric acid as shown by that equation. Okay, we know that carbonates plus acid, you are going to have your salt, water, and carbon dioxide. So this forms the basis of this question. You are to plan an investigation to find which of the two lumps of concrete contains the larger percentage of calcium carbonate. Your plan should include how you'd use your results to determine which one of the two lumps has a higher percentage of calcium carbonate. You have access to all common laboratory materials and a supply of dilute hydrochloric acid. This was a very good question because there are a range of activities that you can use here to find out how calcium carbonate is going to be consumed. Okay, this is concrete. Okay, it's an aggregate of several stones, sand, and a lot of things which are used to make concrete. But within it, there is calcium carbonate. So that's the reactive part that we want. Okay, we could actually look at how fast we can measure how fast calcium carbonate is disappearing. Okay, we could also measure how fast carbon dioxide is being formed. So there are about 3 to 4 methods that we can use to actually answer this question. I'm just going to look at one of the methods that I thought maybe I can share with you. Okay, right. Remember, you need to be specific when you are mentioning quantities in chemistry. Okay, the examiner wants to be convinced that you have been to the lab and you know standard laboratory materials, you know standard masses, standard volumes that are used. So it's of importance that you convince whoever is marking your paper that you know the correct experimental procedures and the international best practices that we use in the lab. Okay, right. So one of the methods that we could use here is we could actually we could actually take our sample of our calcium carbonate. Anyway, let me just outline the steps. Let me just answer it in a stepwise notation so that you'll be in a position to follow what I'm talking about here. Okay, right. So what you could do here, you can actually write procedure. Okay. Right. So I could actually write procedure or steps if you want. Okay. So I'm going to write here procedure. And then after the word procedure, I'm going to put numbers to indicate, okay, to indicate how the experiment is going to be carried out. So you have number 1, okay? So you can actually say measure, okay, measure equal masses, okay, of each sample, okay? Measure equal masses of each sample. Remember, this is a comparative approach, so you want to compare. So masses should not be actually a variable which is going to disturb our comparison. We are going to say the masses are going to be the same. And what are we going to say here? Okay, in chemistry, we don't use very big masses. So you can say 0.5 to 2 grams, okay? Any masses within this range should be acceptable, should be able to give us good marks here. Okay, and then after that you add, okay, add excess, okay, add excess acid, okay, add excess acid. All right, preferably you could even say 50, okay. 50 cubic centimeters. So you add excess acid to each sample, remembering the fact that when you are using chemical reactions, one of the reactants always has to be in excess so that the reaction will go to completion. Okay, so on number 3, what I use, sorry, I've just skipped a stage here. Okay, we measure equal masses, but for us to be successful, let's just remove this and then we are just going to say crush, okay? Because remember, this is concrete, okay? So we crush, okay? Crush each sample in, crush each sample using mortar and pestle, okay? Crush each sample using mortar and pestle. I suppose you're familiar with the mortar and pestle. It is a piece of apparatus that we have in the lab, which we can use to actually convert. Maybe we could be having granules and we want to have powder. Remember that powder is very good because it increases surface area, and therefore our speed of reaction will actually be very big. Okay, right. And then after we have our powder, now we are going to add excess. Okay, so I had skipped a very important step here. So we're going to say add excess acid, okay, to each, add excess acid to each sample, okay? Right, maybe you could say 50 to 100 cubic centimeters to ensure that whatever trace of calcium carbonate is there in the lump will be dissolved. That's why we're adding excess excess hydrochloric acid, okay? Right, and then we say allow the reaction to go to completion, allow the reaction to go to completion, allow the reaction to go to completion. How do you do that when the reaction is happening? Maybe you can monitor fizzing. After fizzing is done, then you can actually suppose the reaction has gone to completion. All right, and then what you do, okay, you filter, okay, filter unreacted mass, filter unreacted mass, okay? Like I mentioned in the beginning, okay, concrete is an aggregate of a lot of substances there. There will be sand, there will be some stones, okay, which we have also crushed, okay? So when we do the reaction, obviously we're going to have a solution of calcium chloride, which is aqueous there. Carbon dioxide is gone into the atmosphere, and we also have water. So these two will be forming our filtrate, but we have now unreacted material, which we have there. So this is what we are saying, that filter unreacted mass, okay? And then what you do next, your next stage is you are going to weigh, okay? You're going to dry, okay? Dry, you want to dry and weigh, okay? Going to dry and weigh. We want to weigh the the residue, okay? So we want to weigh the residue, okay? Right, this stage is very, very important. And then what we want to do here is how are we going to tell that which one had a larger mass of calcium carbonate, okay? Right, so how do we treat our results here now, okay? Treatment of results, treatment of results, okay? Because the key part to the question was your experiment must show us which one, okay, was actually having a bigger, okay, which one was actually having a bigger percentage or bigger composition by mass of calcium carbonate. Okay, so I've explained all these things. Let me wrap this, okay? And then we just want to have treatment of results now, okay? Treatment of results, treatment of results, okay? Right, so how are we going to do that? Okay, obviously it's very, very easy. How do you treat your results? What you're going to do is that sample, okay, if you have lower mass, okay, lower mass of residue, lower mass of residue. What does that mean? It means a lot of it was calcium carbonate, which means a lot of calcium carbonate dissolved. So lower mass of residue means, okay, higher, okay, higher mass of calcium carbonate, okay? Right, so if you are going to actually analyze your results, what you're simply going to look at is if you have a bigger residue, it means the bigger mass did not react. It remained trapped by the filter paper, and a little calcium carbonate passed through the filter paper to form calcium chloride, water, and carbon dioxide. So the lower the mass, so if I have a little residue trapped, it means I had a lot of calcium carbonate. If I have a higher residue, it means I had a bigger if I have high residue, it means I only had a smaller percentage of calcium carbonate. This is one method that you can actually use to answer that question. But you could also measure and collect carbon dioxide that is produced over a period of time. Again, what you need to do is to take equal samples, okay? You react with your excess hydrochloric acid and sample A, sample B, you measure the volume of carbon dioxide produced. Maybe you can say over 5 minutes or over 10 minutes, okay? You draw your two graphs, you analyze which one had a higher mass for carbon dioxide. In that way, you can also actually measure the amount of calcium carbonate that will be present in the lump of concrete here. You could also say, okay, I'll react my two lumps with excess hydrochloric acid, and then I will track how the mass is disappearing, okay, in each. The final mass, okay, will be compared. That one which remains high, it means it had only less calcium carbonate. And that one which would be very low, it means most of it was calcium carbonate. And as a result, we can actually conclude that this sample had a higher component of calcium carbonate, because the key part to this question is your results should actually be used to determine which of these two lumps had a higher percentage of calcium carbonate. I thought I could just discuss this question with you. If you really have benefited from how I'm approaching the revision or the revision sessions to past exam papers, just show by liking this video, and also remember to share the video with your friends at school, and they will also benefit as you have your study groups, and you can also refer them to me. Feel free to visit my page and actually put some questions for your preference. Maybe you want me to do the main theory paper, or you want me to do the multiple choice. Your response will be used to better this platform, so that at the end of the day, your students will benefit. It's bye-bye for now.